Okay, so today we are going to actually do some stuff that isn't completely brand new. We've talked about this before. What does this kind of notation mean? What am I being asked to find in these problems? An angle, exactly. I'm being asked to find an angle. And I know, because we've already done it, that you all know you got a button on your calculator like this, and you can type that in on your calculator. But we're not going to do that. We're going to do this by hand. You will know in the directions, it will either say no calculator, or it will say something like find the exact value. And anytime it says that, anytime it uses the word exact, that means no calculator. Okay, there are some ground rules. These rules are already built into your calculator, so if you are using your calculator, you don't even need to think about these. You just press the buttons and everything will be fine. But if you're doing them by hand, you need to know the rules. And they're pretty simple, but you do have to memorize them. This problem right here, we'll just start with the first one, literally says, find the angle whose sine is 1/2. That's what this says, literally. Notice it says find the angle. Now I need you to think for a second about a couple days ago when we solved equations that look like this. Isn't this really asking the same question? Doesn't this say find the angle whose sine is 1/2? But what happened when we solved these? How many answers did we generally get to these problems? 2. Because, for example, if you're looking at this one, the sine can be a positive number. Where? Quadrant 1.
Quadrant 3.
Sine. Quadrant 2. How do I know the sine can be a positive number in quadrant 1 and 2? Sine is, well, associated with which variable? Sine is associated with y, and where is y positive?
1 and 2.
Quadrants 1 and 2. Oh, darn it, I'm trying to get my phone to go off. There it goes. Okay. Now, we got a little issue here, because there are 2 possible answers to that question, and this one is saying find V1. Find V1. So, here are the rules. If you are doing a sine, a tangent, or a cosecant problem, if this is the kind of problem that you have, you will look for answers in either quadrants 1 or 4. I personally refer to these as right side functions, because they only occur on the right side of the circle. If you are looking at any of the others, so that would be cosine, secant, and cotangent, then you will look in quadrants 1 and 2. I call them top half functions because we only look for them in the top half of the circle. So anytime you are doing one of these problems without a calculator, you need to remember this, because this is going to tell you where to search for your answer. So back to the original problem. It's an inverse sine problem, therefore it can only happen in quadrants 1 or 4. That's it. Those are the only options. When you see this notation, it can only happen in quadrants 1 or 4. When you see a positive sine value though, look here. Can the sine be positive up here? Yeah. Can the sine be positive down here?
No.
Whoa, 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 whoa. What about y down here, folks?
-1.
Isn't it negative? So, the answer to this first problem is going to be a quadrant 1. Does that make sense to you? Not quadrant 2. I know the sine could be positive in quadrant 2, but this function doesn't exist in quadrant 2. Quadrant 2 is not an option. So the only option is quadrant 1. All right, and the sine is 1/2. Well, we've done this part before. What's the measure of this angle? Look at that configuration.
30.
That's a 30-degree angle. So the answer to the question is simply 30 degrees. One answer. All these questions have one answer. Okay, let's look at the next one. Now, I deliberately, you got all this written down, hopefully, because I'm going to have to erase it. I deliberately gave you kind of a tricky one here, because I want you to get exposed to the various ways you might see this number. First of all, it's an inverse tangent. I just erased it, but which quadrants will I find an inverse tangent? 1 and 4. Now, it's a negative tangent. So your choices are 1 and 4, but it's a negative number, so it has to be 4, doesn't it?
Yeah.
If you're in quadrant 1, what happens? No matter what you are, if you're in
Has to be
quadrant
both
1, you're
positive.
positive, right? Okay, so if you're a negative, you can't be in quadrant 1. Now, when I label this triangle, because it says the tangent is √3/3, I would label it like this. Right?
Yeah.
And those numbers don't look familiar to you in terms of a special triangle. So you got a couple of choices. One is you go back to this and recognize, and this is a little bit tricky, but after you've done it a few times, it'll be fine. Recognize that this is the rationalized version of 1/√3. Do you recognize that? So instead of labeling my triangle with the original fraction, maybe I'll label it with the unrationalized, and then I might recognize it. Do you recognize that triangle?
Yeah.
Now you can see this angle is,
60.
whoa, 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 it's across from the 1, so it's got to be 30, doesn't it?
Yeah.
Remember, we're always interested in the angle at the origin. Now, the other way to do the problem, if you didn't think about that, so you've got it drawn, and you've got it drawn with the original numbers, Pythagorean theorem. 9 plus 3, this would be the square root of 12, which is 2√3.
Yeah.
Those numbers aren't ones that I have memorized. So you've got a couple of things you can do. One is try to turn them into numbers that you recognize. Since there's a √3 in the problem, you might consider dividing by √3. This is a little bit more complicated, so you might not want to mess around with this. But that gives you, when you reduce, that gives you the sides that you're familiar with, 1, 2, and √3. It might just be easier to unrationalize. But somehow you got to recognize that's a 30-degree angle. All right? Now, here comes the second thing you have to memorize. When we were solving equations the other day and we had this angle, we answered the question with what? What would you say would be the answer here?
330.
330. And that's what you had to do because the directions said, give me answers between 0 and 360. So you said 330, and you were right. But with this notation, if you are a sine a cosecant, or a tangent. You only exist in quadrants 1 and 4. Right, we talked about that. You're over here. And every answer you give has to be between negative 90 and 90. Has to be between negative 90 and positive 90. Please don't shoot the messenger. I didn't make up these rules. There's a reason for them, and if we have time, we'll talk about it. But those are the rules. So I'm not going to be able to say that the answer to this question is 330 degrees because that doesn't fit in the interval I'm required to answer in. So what am I going to say? How am I going to answer this question in that interval right there?
Negative 30.
Negative 30. The answer to the question is negative 30.
What about the other one? The top one? It's cosine.
Okay, if it's one of the other functions, so that would be cosine, secant, and cotangent, those are top half functions, so all of those answers will be between 0 and 180. All of those will be between 0 and 180. Which is how we've been answering them anyway, Steve, and that's not anything different for us. Okay? All right. Let's try the next one. This one says, we're going to find the angle whose cosine is negative root 3 over 2. Okay? Where will we look for that angle?
1 and 2.
Either quadrant 1 or quadrant 2. Since that's a negative number, it will have to be
2.
quadrant 2. Negative root 3 over 2. So let's see, negative root 3 over 2. Does that look okay to everybody? How big is this angle?
30.
Once again, it's 30. How will you answer this question?
It's 180 minus 30. It's 120.
Be that angle right there, quadrant 2. What's its measure?
150.
150. So the answer to the question is 150 degrees.
So quadrant 3 is just...
Quadrant 3 is not part of the inverse conversation. It's left out. Uh-oh. I don't do secants. So I'm going to rethink this problem. And if I have an angle whose secant is 2,
Cosine is 1/2.
it means the cosine is 1/2. Now, you don't have to do this. It's what I have to do because I don't know why. I just have to. I have to think about this as the cosine being 1/2. The secant is 2 over 1. So the cosine would be 1/2?
Yeah.
If I'm doing it on my calculator, I have to do this. Because why? Why do I have to do this if I'm doing it on my calculator? Because you don't have a secant button. Right? So you gotta change it into cosine. Okay, all right, well, here we go. Where does the cosine equal 1/2? Well, you've got two choices, right? Quadrants 1 or 2. That's it. The cosine is a positive number, which means it's in quadrant 1. And the cosine is 1/2. Cosine is 1/2. Which means the angle at the origin, which is the only one I care about, is 60. So the answer to the question is 60 degrees. Easy. does the sine equal 1? At a what, Delaney?
Yay.
Exactly, exactly. Very good. She remembers that 1s and 0s are very special numbers. 1s and 0s indicate that you are quadrantal. When your sine and cosine are 1 or 0 or -1, you are quadrantal. So we're looking for one of these angles. Now, it's an inverse sine problem, so I'm automatically just looking for one of these. Because this only happens over there.
Positive.
So which of these points, and again, I'm just keeping it simple, I'm using a radius of 1, which of those points is going to have a sine value that's 1?
The top point.
The top one. So what will be the answer to the question? 90 degrees. Very good. There are some problems in tonight's homework where you are asked to do some on your calculator. We're not going to practice that. We've already done that. It's them just type it in on your calculator. You do not need to worry about the rules, the quadrants. You don't need to worry about any of that. If you're doing it on your calculator, it's going to come out the way it's supposed to. You only have to worry about all this if you're doing it by hand. All right? Now, I'm going to give you a couple of tricky ones. What in the world?
So you figure out what sine is, and then you get the cosine into it.
This is one of those that when you go home tonight and your parents say, "What did you learn in school today?" Whip this out. They will be very impressed. This looks hard, but it's really very easy. Like Stephen said, this is an angle. Can I draw a picture of that angle? Well, sure I can. Which quadrant would I draw that picture in?
1 or 4.
Quadrant. Well, it would be 1 or 4. Those are my only options. Since that's a positive number, it will be 1. So I'll draw a picture in quadrant 1 of an angle whose sine is 4/5. And Pythagorean theorem would tell me this is 3. Right? Now I know you've seen that triangle before, but is that one of our special triangles?
No.
No. So you're saying, Mrs. Ford, how am I supposed to know what that angle is? Guess what? You don't need to know what it is, because what do you want to know?
Cosine.
The cosine of that angle. So here's a picture of the angle. It doesn't say what's the angle, it says what's the cosine of that angle. Well, what is the cosine of this angle?
3/5.
The answer to the problem is 3/5. That's it. How about this one? Let's put a negative in here. Let's just make it a little bit wilder and wackier. Okay, so forget about this for a minute. Do what we did a minute ago. Let's draw a picture of this angle. Okay, step 1. Which quadrant are you going to draw that angle in? Quadrant 2. It's an inverse secant, so it only exists up here. It's a negative number, so it's here. Oh, whoa, 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 Miss Ford's got a bad problem here. Anybody see what's wrong with it?
Yeah, there's no. It doesn't work.
What's gonna happen when I try to draw this? gonna look like that, right? Is that good? Now, let's make this a 13. Now we can do it. All right, what's the next step? You're missing something in the picture. What are you missing?
Other angle.
Do we need this side?
Yeah, triangle here.
So let's see, that'll be 13 squared, so 169 minus 16. Did you get the square root of 153? Now, you certainly have that triangle, you have no idea how big that angle is, but you don't care, you just want the tangent. So what's the tangent?
The square root of 153 over negative.
Negative root 153 over 4? All right, let's try one by yourself with your partner. By yourself or with your partner. Let's find the cosecant of the angle whose cotangent is 5/8. Last one, then we'll review. Let's see if you can get this one. Find the cosecant of the angle whose cotangent is 5/8. So you got to draw a picture of the angle. So you got to figure out which quadrant you're going to draw it in. Then you're going to label your sides.
No, sorry, you want 4.
Probably you'll need to do the Pythagorean theorem. Carter absent today. Ben's absent today. Reador absent today.
Tangent over it.
Tell us, sorry, opposite version.
Tangent is away.
So opposite.
Cosine adjacent over
What quadrant did you put it in today? Good job, quadrant 1. Did you put a 5 here and an 8 here? And then this was the square root of what? 89? Is that right? 64 and 25, yeah. What's the answer to the question then? We need the cosecant of that angle. The cosecant would be root 89 over 8. Any question about that? Okay, you're going to practice some of those tonight. All right, let's go back. We got to get a quiz in over the first few sections of this chapter. This is not on the quiz, obviously, but all this review stuff. So let's get our practice quiz back out that we had out yesterday. And did anybody keep track of how much we've gone over? How far did we get on this practice? We're in the middle of 2?
Yeah. No, I think we finished it. We finished it.
Well, just in case somebody didn't get it done, let's wrap up number 2. This is a sketch of a sine function. Okay. I got to draw a sine curve. Actually, I'm going to draw an upside down sine curve. Normally I would start right here, right? This is where sine curves start. Where am I going to start this one?
It's going to go down.
Pi over 4. This one has a phase shift or a horizontal shift of pi over 4. It's a negative sine curve, so it's upside down, valley first and then hill. Its amplitude is 2, because of this. And what would be its period? What's its period supposed to be?
2 pi.
2 pi. But we've changed it because we put in this number, so the period is actually 4 pi. That means I'm going to start right here, and I'm going to march 4 pi. So this number right here is going to be 4 pi plus 1/4 pi, or 17/4. This will be the midpoint, or the average, of 1 and 17. 1 and 17 makes 18, and half of that is 9. This will be the midpoint of these two, so 1 and 9 is 10, and half of that is 5. And 9 and 17 is 26, and half of that is 13. This problem has no vertical shift because there's no number up here, no number tacked on to the end. And its frequency is the reciprocal of its period, so 1 over 4 pi. Any question about any number I put up here or anything? If this would have been a cosine problem, I would have done nothing different. Absolutely everything would have stayed the same, except the shape of the picture, right? So if this had been a negative cosine, I would have had all the same labels, but I would have had that purple curve. Nothing would be different about how you did it. Okay? All right, let's look at the next one then. This one's easy, I think. What does that 270 to 360 thing mean?
Quadrant 4.
Quadrant 4. So you're going to draw a triangle, part of your butterfly bow tie. You're going to draw a triangle in quadrant 4. And the cosine is 5/13. So then what will you do?
Make the 5.
You'll figure out the other side, Pythagorean theorem, that would be -12. Everybody see why it's negative? And then you're going to fill in the blanks. What would the sine be?
-12 over
-12/13. What would the cosecant be?
13 over -12.
-13/12. What would the cotangent be?
5 over 12.
-5/12. The tangent, -12/5. And the secant, 13/5. Everybody good with that? Now we need to find the exact value of the sine of 4 pi over 3. We've done a lot of these in our time, so we should be okay. How would you start this problem? This isn't an absolute mandate, but we've always started them by doing what? What, Maria? Changing it into degrees. Yeah, we've changed it into degrees, and that's real easy to do. I can do it in my head, because I know pi is 180 divided by 3 is 60 times 4 is 240?
Yeah.
Madeline, you're not chewing gum today, are you?
Yeah.
She just smiles.
Yeah.
Okay, here we go. Now what do? I've got it converted to degrees, so it's a little bit more manageable for me, so what do I do now?
You go 240 degrees.
I go 240 degrees, and remember, we start here. So 240 would be all the way around to about here, right?
Yeah.
Make my butterfly bow tie piece, my triangle. Now this angle was 240. This is 180. How much past 180
60.
did I go? 60. Remember, the angle at the origin is the one you care about. Across from the 60, this is a 30, 60, 90 triangle. Across from the 60 is
Squared.
root 3, 2, 1. And actually, both of those are negative. Remember to make yourself stop and put the negatives in, if there are any. Now, what do we want? We want the sine. So the sine will be
Negative root 3 over 2.
negative root 3 over 2. Any question about that? Find the area of the shaded region. Okay. There, well, as with all things mathematics, there's more than one way to do this problem. So what is your thought when it says find the area of that shaded region? What would be your thought?
Radians times radius equals the arc length.
Equals the arc length, okay, and then what?
I don't know.
Well, you can actually do the problem that way. I just wondered, we hadn't talked about it, so I wondered if you maybe
I
had
would've,
some thought.
I would see how long, I mean, then the arc length would be how long that was. And then you would have, I don't know, you would have to do an equation. I can't just say it.
Would it be possible to do like, find the area of the whole circle and then divide top or figure out like the fraction of 70 over 360?
Exactly. That is probably the easiest, fastest way to do the problem. Stephen, what you were talking about will work, but I think the easiest, quickest way to do the problem is is what Maggie said. Find the area of the whole circle. Just what's the area of this circle going to be? 25 pi. How do we find the area of a circle? Pi r squared. Pi r squared. Pi r squared. So area of the whole circle is pi r squared. So this whole area would be 25 pi. Now, if you weren't sure, if you couldn't hear Maggie, or you weren't sure what she said, you couldn't quite understand what she was talking about, if I said to you, what is the area of that? Wouldn't you take 25 pi and just cut it in half? Because that's half the circle, right? Well, this isn't half, obviously, but it's a fractional piece of the circle. So instead of taking half of 25 pi, we'll take 73/60ths of 25 pi. Because that's the fractional piece that's shaded. 73/60ths. So let's see, that's going to cancel. What's 7 times 25? 175 pi over 36. That's the answer to the question. So the next time you see this problem, if this is a 110, you will do everything exactly the same except what? 110/360ths, right? That's easy. All right, number 6. Now, Stephen, this one specifically asks for arc length. S is arc length. So what did you say, Stephen, about arc length?
It's the radius times the radians, so you have to take the degrees and put it into radians.
Okay, so if we're going to use that formula, you're right, we need to change 100 degrees into radians, and how do we do that?
Proportion.
Pi is to 180, as something is to 100. Remember, pi equals 180, these match. We want to know what matches 100. Hmm, 5 pi over 9.
Just times it by 4.
So your arc length will simply be 4 times 5 pi over 9. This is 4 over 1, so it's 20 pi over 9 inches, because that was inches. Now Heidi's already looked ahead. She says, hey, look what's on the very next page of the packet. More review problems. Now, I don't want to bore you, Lord knows I would never want to do that, but let's look down through here. Now, number 6, we didn't have on that quiz that we just looked at, that old quiz we just looked at. But maybe we should do number 6, because that's different. Find the length of a shadow cast by a 16-foot pole if the angle of elevation of the sun is 27 degrees. Now, in order to answer this question, you would need a calculator. Could you draw a picture and set up an equation for it? Here's the ground, here's the pole. And the pole is 16 feet tall. And the angle of elevation of the sun is 27 degrees. So if you're down here, you're looking up at the sun. Here's the sun. This is 27 degrees. What are you looking for? Hypotenuse or adjacent here? Which one are we looking for?
Adjacent.
Shadows on the ground, folks, right? So what would be the equation you'd set up? You would need a calculator to solve it, but what would be the equation you'd set up? Tangent 27. And Delaney, why did you choose tangent? You're exactly right. Well, why did you choose tangent? Exactly. Hypotenuse is involved, so we got to use tangent. And then we could solve that if we had a calculator. You will not have a calculator on this quiz, so you wouldn't be able to do any more than that right there. Okay, now if you look at the, by the way, the answers to those practice problems are on the back here. If you look at the next page then, there's another quiz. This one is a little bit bigger than the one we just practiced. Let's see, is there anything on it that looks like it might be confusing? Here's what I'd like to do. You have homework tonight over the inverses that we talked about, the inverse functions that we talked about. I think I'm going to move our quiz to Tuesday because I'd like you to have the weekend, those of you that are so inclined, to do any of the practice problems on that review sheet or this other quiz. And then we can talk about those questions on Monday, and then we'll take a quiz on Tuesday. So is everybody clear on that? The quiz will cover sections 4.1 to 4.5. So what we learned yesterday and what we learned today will not be on the quiz. Everybody clear on that? All right, you've got a few minutes. You can get started on one thing or the other. Stephen, would you turn the video over? Thank you. You can get started on either your homework, or you can do some of this review while I'm here